And so we move on to the last of the reasons for the coastal defences, which is sea level rise due to climate change. Just before we jump into that, let's remind ourselves of where we've been so far. This is all about reasons for coastal defence, all about presenting arguments. And we've broken them down into three main elements. People live near the coast. We've visited all those locations around the world, like Miami, LA, Singapore, places like that, where we have seen just how high density the housing is around about the coasts. And therefore, here comes the argument, if those areas are eroded or flooded, the economic and social consequences of that would be significant. Therefore, they need to be protected by coastal defences. And then we come across to the coasts are important economically. We had three different examples of those. Tourism, we went to Portrush and Tenerife, the ports including the port of LA and Shanghai, and fishing including Kilkeel Harbour. Each of those locations we saw about how the economics of those areas and the economies of those areas were important and related to the coastal areas. So coasts are important economically, they generate money. Therefore, damage from erosion or from flooding would have serious economic consequences. Therefore, there's an argument to protect them by coastal defences and management. So the sense of argument is very important coming through here. But the last one then really in many ways overlaps those two, because against all of those, right, coastal flooding or erosion, those issues are going to be amplified by the challenge of sea level rise from climate change. In a warmer planet, our sea levels are higher, and all of those risks that we looked at for those other locations become amplified and magnified. Okay, let's go on and take a more detailed look at that. First of all, is sea level rising? Well, here is some data showing exactly that. If you look at the graph, what is the trend on this graph? What's the verb that you would use? Rising? What's the adverb? Well, I want you to notice that in many ways there are three sub-trends here. It is increasing at an increasing rate. The rate of sea level rise is going up over time. If you look at those time periods there and the height rise, you can see that not only is it rising, but it's rising at a more rapid rate over time. So the first thing that we need to understand a little bit better is why this is a particular threat and a particular challenge. And this graphic is going to help us to do it. On the left hand side we have got sea level now, global sea level. On the right hand side we've got that higher global sea level that is resulting from climate change. Let's add on a few tides and other bits and pieces and we'll see just how at risk these areas are. Here we go. So the first one is a high tide known as a Neap high tide. We don't need to go into the details of why that's called that or how it's caused. All we need to know is that this is a high tide that is not particularly high. In both cases, you can see here that the coastal areas are below the effect of that high tide. But there's another type of high tide called a spring high tide, which is a very, very high tide. If Neap is a low high tide, not a low tide, not a low tide, it's a high tide, but it's a low high tide. Oh, yeah, you got it? Yeah. The spring tide is a very, very high tide. And notice what is the case. In places where now you've got urban areas, cities, coastal cities that are above the level of the spring high tide, when you factor in global sea level rise with climate change, they will now become flooded much more regularly. That's why sea level rise is a challenge. Not necessarily that these places are going to be flooded all the time, although there may be some areas that we lose entirely. But it's when you put on those spring high tides, places that would not flood will flood. But there's another thing that we need to put on over the top of this again. and it's called the storm surge. Now we're going to meet storm surges in more detail whenever we do hurricanes, and we'll explore why it is that they occur. So if you're watching this video after we've done hurricanes, you'll know why. I'm not going to go into the reason why now, because all we need to know is that on top of this spring high tide, if you get this storm surge, there are places in the world today that are flooded. So Mumbai would be a very, very potent example of that, built as it is on large areas of reclaimed land just above sea level. So when you've got the spring high tide and if you get a storm coming along with that, that can flood some of the coastal areas. But if we take a look here with sea level rise, with climate change, it's not just the storm surge that floods, it's the spring high tide that can flood, and the storm surge will flood even more. So what we're doing is taking areas that are currently flooded infrequently, and once we put in the sea level rise, we're going to make flooding there much, much, much more frequent. And it's that is the key thing. Yes, we will lose some areas entirely under the water, but what the real risk from sea level rise for many, many places is that the infrequent becomes frequent, with devastating consequences. So we need to understand a little bit of why the sea level is rising. If those are the consequences, what is it that's causing it? And there are two main reasons. The first one is called thermal expansion. We'll explore that in a moment. And the second one is to do with the melting of glaciers and ice sheets. Let's take a look at thermal expansion first of all. So if this is the current sea level rise and this is the current temperature, what will happen as the temperatures rise, as you heat a liquid, as you heat anything, it will expand. So it can't expand down, so it has to expand up. So as the temperatures rise, the seawater is heated and expands, and that sea level goes up. That thermal expansion. So let's take a look at this graph which shows thermal expansion in glaciers. We'll look at glaciers in a moment in a little bit more detail. This is the sea level rise measured by satellites that are measuring this to a very, very high degree of accuracy. And this is the total sea level rise since 2005. Look at that, from 4 centimetres up to 8 centimetres of a sea level rise. That really is quite considerable, isn't it? And there is the contribution of thermal expansion, and there is the contribution of melted glaciers. But instead of putting those two bars side by side, we've stacked them up on top of each other. And when you stack them up on top of each other, like 1 potato, 2 potato, that kind of thing, that gives you the total amount. The blue element gives you the amount from glaciers, the red from thermal expansion. You can see that the role that the two of those have been having. Right, let's take a look at the other one, the melting of glaciers, and for this we're going to come to the continent of Antarctica, and we're going to come into the western part of Antarctica to a place where you have got the ice sheet melting. Now here we have a map of where the ice of these glaciers on this continent are melting most. And the red is where you're getting a reduction in height, which is showing that they're melting. And you can see that there's definitely a pattern. Where is this melting taking place? Now, when you're describing the distribution, it's where things are and where they're not. Where things are and where they're not. So where is the melting taking place here? North is at the top, west, east. Okay, so you can see it's mostly over to the western side, some here on the eastern side. But where's it not? It's not in the center. This is melting from the edge because it's beside the sea. And if the sea is warming, we'll look in a moment how it does it, it's no surprise that it's melting at the edge. If you take an ice cube, put it into a glass of water, the ice cube melts from the outside in. It's exactly the same here. It's melting from the outside in. But let's go in and take a look at this glacier in particular. It gives us a very, very graphic illustration of some of the challenges we're facing here. This is called Thwaites Glacier. It's also known as Doomsday Glacier for reasons that we'll find out as we go in and have a little bit of a closer look. Let's find out a little bit more about this. Here is the continent of Antarctica. In actual fact, a lot of the places that have ice in them at the moment are just slightly below sea level, including Thwaites Glacier. And if the sea level around the world was lower, you would find that Antarctica was made up of loads and loads of islands. So there's Thwaites Glacier there, and it is a massive, massive big glacier. To give it a bit of scale, it's about the size of Britain, of England, Scotland and Wales. Yeah, the size of the whole of Great Britain. And it accounts for about 4% of the world's sea level rise every year. A huge figure for this glacier. But what is happening with this is that it is melting faster. It's increasing. That melting rate is increasing. And the worrying fact, and why it's called the Doomsday Glacier, there's enough water locked up in it if this entire thing were to melt to raise sea level by more than half a metre. So how does that occur? Now let's take a look at this graphic. I'm going to just unpack a little bit about the mechanism of how this melting occurs. One of the things you need to know about a glacier is that it does flow. It flows very, very slowly compared to a river, but it does flow. It's a moving body of ice. So what you're getting is the ice flowing down here towards the sea. And as it gets to the sea, that's whenever you get these icebergs coming off. They go into the sea and they gradually melt, adding more water to the sea, increasing the level. Does this look like any of the river features that we've met before? I wonder, can you see that? I mean, are you seeing here some similarities to a waterfall, for instance? You're seeing here the ice being unsupported. It's supported here, and where it is in contact with the seabed it remains stable, but here it is much, much less stable. And this is where the water comes in underneath. The ice is not supported as much, and this is where you get the ice coming off, forming these icebergs. So what happens with this in a warming world? What would happen if you introduce warm water here? What do you think is going to happen next? Let's have a look. Do you see the difference? In comes the warm water. And what happens is that it undercuts and it erodes, it's the wrong word, it melts the ice here underneath, and it moves back where the ice is in contact with the ground. This is the bit that's more stable. It increases the amount that is unstable, and because this is unstable, it will then collapse. Chunks of ice will break off to form these icebergs. So as this warm water comes in and undercuts this, the ice is less stable and melts more. And it's that warming of the water in a world where climate change is a challenge that is causing that to happen. And we just finish off again by giving a sense of scale. There is that Thwaites Glacier against Great Britain, nearly the same size as England, Scotland, Wales. Enough there, if that all melts, to raise global temperatures by half a metre. So we have looked at sea level rise on a number of places as we went round the globe. So we're just really going to finish by coming back to one of the places that we went to before, and that is to Mumbai and the threat of sea level rise there. It is estimated that the Arabian Sea, that's the sea to the west of Mumbai, could begin flooding most of Mumbai at least once a year by 2050 due to global warming induced sea level rise. And again, remember what I said to you. The fact that the sea is rising, the sea levels are rising, means that places that are flooded infrequently will tend to be flooded more frequently as a result. Let's take a look at some of the impacts of that on some of the poorest and most vulnerable people in Mumbai.
Mumbai saw a record amount of rainfall this monsoon season, with about 2/3 more than average. But its rising sea levels, attributed to global warming, is causing the most concern. Families like the Devenders fear the waves, which now crash close to their doorsteps, will someday crash into their homes.
By even hearing about the rising sea level, we feel afraid. What will we do? We've been living here for so many years. It would be good if the government could do something to help us.
Mumbai and other fast-growing coastal megacities in Asia, like Jakarta and Tokyo, are particularly vulnerable to climate-related flooding. These cities often drive the national economies. Environmentalists like Debbie Goenka say governments need to prepare for the inevitable.
So I think what is necessary is that Mumbai is going to be underwater. We need to plan for that eventuality. And what is required is to plan a new city to replace Mumbai as and when it gets submerged. And ideally, to my mind, it should be somewhere inland at a pretty substantial elevation.
Research released by Climate Central, a US-backed panel on climate change, says an estimated 300 million people are at risk of coastal flooding in just 3 decades. And by the end of the century, 200 million more could permanently lose their homes. This even if countries meet their emissions targets set out in the 2015 Paris Climate Agreement. But in reality, nations are far from meeting these goals. So for people in cities like Mumbai who live on the edge, this inaction could see their livelihoods destroyed and their homes lost forever. Afzal Ahmed, TRT World.
So let's go in and take a visit to that area that we've just been seeing there in the video, and we'll get a bit of a sense as to why these people are so vulnerable. One of the great tragedies of climate change, the climate emergency we face, is that the people that are most vulnerable in a society, the poorest people, are the ones that are most likely to be greatest, to have the greatest impacts on them. They're the most at risk, and you can see this very much in the case here. This is a shanty town. Shanty towns are built in areas of any available land, and if we zoom out a little bit here, we'll see that this is quite close to some more affluent, well-off areas, but you've got this relatively low-lying peninsula coming out here that wasn't really built on. The only thing that was here was a 17th century British fort, which was built up on a slightly higher bit just at the end of the headland. Higher because it'll be above the area of where you're going to get it flooded. But this land was available because it's low-lying and is more at risk from flooding, and these people have built on here. But you can absolutely see then, as a result of that, that they are particularly vulnerable to the flooding that might or that will occur here, and that will occur more regularly in a world where climate change is a thing. Let's take a look at this link, because it's going to take us into this area that we've just been looking at, and really just put on some information about that sea level rise and the sea level change that's going to take place. Let's just give it a moment to load up. So what you've got on the right here is the amount of flooding that will occur with a 2 degrees of warming, and on the left with 4 degrees of warming. So let's zoom in a little bit to the location that we were just visiting. Just drag this across, and I'm going to want to zoom in a little bit more. And here is the peninsula that we were just visiting. Now this with 2 degrees of warming shows how much of this area will be at risk from flooding. And you can see in contrast with the more affluent areas just how at risk these folks here are. But with 4 degrees of warming, that whole peninsula is basically gone. And what did these people do? Where do they move to? Who's going to pay for the relocation? Who's going to help them find the land? Where will they find the land with so much of Mumbai at risk from flooding? And with 4 degrees of flooding, you can see here that there's also infrastructure at risk. Even with the 2 degrees of flooding, there's the railway coming through here. The impact on Mumbai of this in terms of the regular flooding could be considerable. Now remember, what we're talking about here is not necessarily that these areas will be permanently underwater, although some might, but areas that are flooding infrequently will be flooding very, very frequently. And if your home is flooded, you're in theory, if you were in Britain and your home was flooded, you'd be out for months while you had the insurance companies coming in, helping to repair that and deal with all of the damage. If you're living in a shantytown in Mumbai, you're not going to have that degree of protection. So it just shows you that degree of vulnerability that these people are living with as a consequence of climate change and sea level rise. Okay, that brings us to the end of our grand tour. We've been travelling the world looking at all these reasons for coastal defences, and the reasons were giving us arguments. Arguments like people live near the coast, therefore the social and economic impacts of flooding and of erosion will be great, therefore we need to protect them with some degree of management, would go the argument. Secondly, coasts are important economically for tourism, ports and fishing, therefore the economic impacts of flooding or coastal erosion would be great, therefore we need to protect them with coastal management. And then finally, throw into the mix the sea level rise. As a result of thermal expansion and melting of glaciers, what is happening here is that the base level of the sea is going up, so areas that would be flooded infrequently today by spring tides and storm surges will be flooded very, very regularly in future by spring tides and storm surges. And in fact, we will lose some areas entirely. So the fact that sea level rise is happening really amplifies, magnifies those arguments. Those arguments are more important because sea level rise is happening, and in particular when you throw into the mix, these people living near the coast aren't just where we started in Miami with all those beautiful big apartments. These are not just rich people who can afford coastal locations. We have finished with the most ultimate contrast of those poorest, most vulnerable people in any society who are going to be most at risk from climate change related sea level rise. The challenges are real, the time is short, and we need to be taking action for this.